All right, we're recording.
Sounds good. So today we'll be talking about an introduction to drone design. Um, and this was part of the key project at Juicy Merced. So I went to get ahead and designed a drone earlier, maybe like a month or two ago. Let me show some pictures of it. So this was actually 3D printed. And in fact, I think I shared this one in the previous one of the previous presentations. But you have a pretty much like the platform, and then you have the arms, and then you attach the motors over here, and of course you have the screws and nuts, the fasteners that hold everything together. The idea behind this middle piece is to try to keep it sturdy enough so that it doesn't bend, since this is so long, you know. And instead of making the whole thing super thick, just make the center line thick and hope that that should be good enough until we fly it and crash it, right? And then these are actually just store bought on Amazon. These spacers. So you can see these holes right here. These were actually designed with the spacing in mind. Since I already knew I was going to use this flight controller, so I went ahead and uh, you know took the distance of these two holes and also put that onto this platform. So that way you could just screw it in. So you can see it's got a couple small spacers, but the screws go right in. So I guess it's kind of like you have to know which parts you're going to use in order to design it right. You can see the screws at the bottom right here that I was talking about. And finally, once you add the nuts, the motors, these are fairly the spacing on these I think is pretty common, so I think it should be good with just using a standard design with the whole pattern right here. And the camera, well, yeah, once again, it depends on what camera you're using. This bracket was also designed specifically for this camera. As you're gonna see, it bolts right here actually. And this is the top piece. I'll show the 3 model in a bit. So that's how the camera looks like on the top part, which is upside down. Then you have the electronic speed controller. Once again, measure the holes, and if you include that correctly in your design, then everything just bolts up pretty easily. These screws are pretty long, so they were pretty helpful. And this is the bottom view of that. Um, and one of the things I used was Velcro, just because some things they're so light, or um, they're not too critical, like they're not gonna fly off. Like Velcro is enough, so that's what I use here. I think I forgot what I put here. Oh yeah, I think it was the battery eliminator circuit. That thing weighs like just is really light, so the Velcro was enough to hold it in place. And this is with the top piece on top of the drone. Once again, we have the Velcro. Velcro is our friend, and this is the video transmitter. So you're gonna see with that one, I actually designed these holes right here. So that I could put a zip tie in addition to the um, Velcro, just because they kind of like pre-made, and it's I guess we could make like a custom bracket for it. But in my case, Velcro is a lot lighter than having an extra plastic piece to hold it. So I just went with the Velcro. With drones, one of the things you're trying to reduce is weight, right? Um, it reduces your ability to fly longer if you have um, they're a really heavy drone.
I have a question.
Yeah.
So, at this point, I was wondering about the size of the holes for the zip ties. Um, if they're long like that, wouldn't the zip tie go left and right? Couldn't it slip off?
Uh, yeah. So it potentially it could slip, let's say from here to here, but because it's pretty much enclosed within this gap and this gap, so it's not gonna fly off the completely off the drone. So yeah, it might slide a bit to the left or to the right, but if you tighten it pretty well, um I mean, and even if it does slide a bit, it's not gonna fly off. This piece, that's the important part, right? We don't want these pieces fly off mid-flight,
I would
and
say you could even use 2 zip ties, one on each end of the hole, and then that would probably secure it even better.
oh yeah, so that's a very good point. Or actually building off of that idea, that was a good idea. Maybe I could add like an addition right here, maybe halfways or something. So that way it's two holes instead of one big one, or three small holes,
True, but you also want to decrease weight, so I guess if that's good.
Yeah, kind of trying to compromise. So there's that zip tie, right? That we were
Yeah.
just talking about. And for the battery, I once again I did the same with the Velcro. Um, of course, one piece on the drone and then the other side on the battery. And the battery's pretty heavy, so you kind of have to strap it down. In addition, they have these straps. This actually came with the battery, so that was pretty helpful. Um, yeah, so I guess just it's just safer when you add something so light as a strap. It's just better to use both the Velcro and this. In my scenario, right? If you maybe design like brackets into it that could hold it, then you might not need the strapper, but with this design you do. This is the final looking product. Oh yeah. So let's go over to Fusion. So I designed these pieces individually. You can see them over here on the left. But let's take a look at the assembled model. So these arms are pretty much the same piece. You pretty much have four of the same parts. And actually, if you take a look at the picture, oh yeah, right here. This one has these like cutouts, but I ended up crashing that one enough and breaking them so often that I decided to make it completely solid. Um, this this one seems to be a lot better in terms of not breaking. Um, they actually survived a pretty hard crash, or three of them at least of the four. So that's a lot better than four of them breaking. So, uh, once again, we have the bottom. I call it the bottom frame, and then the top frame. Um, and then there's that little camera piece right there. So what I did was I inserted these individual files into the Fusion, into this Fusion 360, and you can see right here, they're pretty much like components, I guess, of an assembly.
How did you create the actual components? In Fusion 360 or in something else?
So I use Fusion 360. Let me open a couple of these. Oh, what happened? I guess what?
You clicked on the top frame, QRD top frame.
Okay. So let's go with the base and just that one for now. Let's see if it works. Okay. Yeah. So over here at the bottom, you can see the steps. let's go at it one by one. So I like doing things pretty simple. So first start off with the rectangle. So you kind of, this is like your real estate. You have to measure your parts and kind of estimate, oh, I need 150 millimeters in order to fit all this. And so that's what I did. And if it ends up being that you need more space, you could go ahead and edit this and make it longer if needed. I made these holes. These are for the standoffs. And I tried to space them evenly just to, evenly distribute the crash forces, if any, or more like when you crash.
Does that matter a lot? Like even at the smallest hole, it would affect the balance of the drone.
You could, I mean, yeah, you want to have your drone probably as equally balanced as possible. But you could do some last minute adjustments, specifically with the battery. So I kind of try not to worry too much about that until I place the battery, and I try to just balance it until it's feels more or less in the center. Otherwise, let's say if you put the battery all the way in the front, then it's going to be front heavy, and then your motors are actually going to be compensating for that. So it might affect your flight. So continuing on, so the mirror function is pretty useful. You could just do that. In fact, I could just model half the thing and then use the mirror to complete the side. So I added this rib right here to try to make it stronger on the outside without making this whole piece thicker. What I might end up having to do is add a few ribs, like diagonal pieces, like one over here, one like that, just because in the recent crash it actually broke pretty bad. But then again, it fell pretty hard, so that probably would have done it either way.
Are you going to tell us about your recent crash?
Yeah.
Did you show us the video for that last time, or was that the first one?
No, that was the first one. In this second one, or this, not the second one, the most recent crash, my camera was acting up actually. I wasn't able to record it, so. But it pretty much, I let a friend fly the race drone because he's familiar with other drones. So he's an experienced pilot, right? Or right, he has experience with other types of drones, but he hadn't flown a race drone before. So I thought, I talked to him about this drone, and he wanted to fly it, and I thought it'd be a good test. I made sure to emphasize that be careful. It's a lot faster, but I don't know.
Then you crashed it?
Yeah, it was pretty much like a takeoff, vertical, and it went up so fast that I think he panicked, because I panicked just watching it, and then it just came straight down. That was pretty much, I don't know. Good to know, I guess.
Yeah.
That's the reason that they have flight simulators, right?
It's
So
stress test.
in fact, actually, we might have to do some flight simulations, but we could.
Do they have flight simulators for drone or like race drones?
Yeah, we could probably look into that maybe after the presentation, but I could give you guys some pointers on which ones. And then so these holes right here are actually the ones for the mounting. Did I label it? Oh no, I didn't. You could edit the sketch name. So like mounting holes for the controller. So that's just good practice. And then some more holes. These were for the Oh yeah, these were for the arms, right? Yep, because the arms go stick out this way. Um, but what happened? Oh yeah, there it is. So just kind of one step at a time. The way I tried to design this one was such that if something broke, you could access the screw right away without having to take like let's say an arm broke. I don't have to take off so many parts just to access that arm, the screws on that arm. This one is pretty much if something breaks, you could easily just replace it.
Yeah, it
I
all
mean,
looks designed really well.
uh, we're gonna find out after we crash it enough. So the top frame. So I guess the important part between the top and the bottom frame, unless you do a unit body frame, so like the top and the bottom are all one frame. Which so the thing with having more pieces like this is if one piece breaks, you could replace just that part. If you have like one single uh like the whole frame is one piece, then let's say you crash it, then you got to replace the whole frame because it's just one part. So it's good to have a few pieces at least.
I have a question. So let's say one side chipped off. Are you gonna chip the same piece off on the other side, or are you gonna print a new whole one?
uh so for example, this part, or like which part?
Let's say one of the screws came off, or one of the screw holes came off on the bottom right. What are
Right.
you gonna do in that case? Are you going to go to the diagonal opposite one, break that one off too, to make it even, or are you gonna print the entire thing again?
If I'm out in the fields, flying, and it could like a piece breaks off, but it's non it doesn't impede the functionality of it, I might just keep flying, until something else breaks. But if I'm at the house and just replace the whole piece, yeah, just because um you know if it'll probably only take 10 minutes or 20 minutes or something to replace it. But yeah, the important part with this one is you have to match these holes with the bottom holes, right? Otherwise, I think you can see that right here. If I go to top view, that these holes line up right here. If you look at it straight down, they line up pretty well. And
How
now
did you do that? Did you use like some sort of calculations to see where the hole would be?
yeah, so I think you could copy the sketch. Otherwise, yeah, just measures. For
Oh,
example, they're 50 millimeters apart, and there's 5 inches inset. So like I think I used the offset. So this is 5 millimeters away from this one, but also this is 5 millimeters away from that. So yeah, you could just use math and you know do it that way. But yeah, I think that was pretty much it. I think, let me see if I show the arm real quick. Oh yeah, and at the top you can see the version number. So it's you can see that it took me, this is version 3, this is version 4. So it might take a few iterations to get it right. Um, simply overlooking a small number, you enter in a different number, and then things don't match up, and you gotta change it and reprint it. I think here. So these were the lines that I showed over here that I ended up taking off, these cutouts. But once again, yeah, just kind of start. I like starting with the basic shape and just cutting from there. And sometimes it could get kind of like nasty, looking at so many numbers in one screen. But
What's the extrude step?
extrude adds the so you have you start off with a sketch.
Oh, and then okay, I
And
get
you
it.
extrude the cuts. So you extrude the sketch. So you're either adding or removing material, like like a third dimension. And once again, yeah. So like Armand was saying, these holes were calculated to be at the precise spot so that when you place them over here, that they line up with this bottom frame. It kind of looks funky, like they kind of look like they don't line up, but they line up. I think it's just this I don't know, the way this thing shows it. There we go.
It seems like you have to look at it like straight up and down for it to line up perfectly.
Yeah, this is my first time using Fusion 360 for an assembly, so I thought it's pretty new to me, actually. But yeah, that's
So how did you get all the parts on the final drone right there to like piece it together perfectly?
so I import individual parts. So for example, let me click on a random piece. So I click on insert to current design, and it'll pop it up right there. And then I could go ahead and move it or rotate it if needed, but I'm just gonna leave it there for now and just press OK. And from here I could, move it as
Okay.
needed. So this is, do you see how it moves as one piece?
Yeah.
I could attach this to there using, they have like joint, this joint function. So I could say I want to attach the bottom of this hole to, let's see, let's pick a hole over here. Let's see if it allows us to do this one. It might give us an error. Oh, I think it might not look pretty, but it allowed us to do it. So now it's joined together, right?
That's pretty neat. So you connect on the screw holes that you make. All right, it knows where the screw holes are and how to connect them.
Yeah, so I'd use the screw hole in this case, but you could probably use other features. So let's say I wanted to join this edge with this bottom edge. It would probably allow me to do that. So like corners, faces, you could probably use those features
Yeah.
also. So actually, if I press view joints, these are all the joints that I made to make it together, make it one piece, or yeah, like an assembly.
Yeah.
This assembly is just for you, right? Because we're not actually 3D printing this. You're 3D printing the individual parts, right?
Yeah, so this is just for I guess to kind of visualize it in one assembly. I I like this view. Yeah, it kind of gives you a visual of what it is going to look like. And in some places, I not for these motors, but in some places you could find, like, let's say the 3D model of the motor or whatever component. So in some cases you could actually model out like to the screws and nuts, like to that detail, if possible, if you can find the parts. But in this case, it's just like a basic frame only. But yeah, I want to probably just end it right there. If there's any questions.
No, I don't have any questions.
All right.
Thank you.
Yeah, then let's go ahead.